Hello, class. We're about to start sections 4, 7, 4, 8, and 4, 9 today. We're going to cover the whole week today, so you will have all of the material you need for the week. So we're going to start on section 4, 7 on page 447. And as you see here, we're to do 1 through 23 odd. And as we've done before in the past, I would do some of the problems, but not all of the problems. So you will have in your notes when you turn in your the work for this homework, you would turn in the problems I go over and also the problems you're supposed to cover. Now on page 447, before we get into the actual lesson, I want you to look at the summary activity, which gives us a summary of the things we would need for this lesson. Okay, number one, the imaginary unit denoted by I is the number square root of -1. The number I is defined to have the property I squared equals -1. That will come in handy a little later. Any number that can be written in the form a plus bi, where a and b are real numbers, and I is the imaginary unit, is called a complex number. The term a is called the real part. The term bi is called the imaginary part. In the quadratic formula, which we covered in the previous lessons, the expressions b squared plus 4ac, and they're talking about the value under the radical, is called the discriminant. Its value determines the number and type of solutions of a quadratic equation. Now, number 4, it tells you the solutions to a quadratic equation. So basically, if your discriminant, the b squared minus 4ac, after you do the squaring and multiplying and subtracting, you get a positive number, it'll be two real numbers. You get a 0 is one real solution, and then negative is two complex solutions. So we're going to go through this. Let's take a look here. Okay, we're going to do problems 1, 5, and 7, and then we'll move on to the next page. Okay, problem number 1. We have the square root of a -25. All right, first of all, let's forget about this negative sign for a second. The square root of 25 we know is 5. So we know our answer is going to have 5 in it. Now, because it has this negative here, in your mind, now you don't have to write this out. I'm writing this out this first time so you can see how this answer is derived. But in your mind, this square root of -25 is the same as square root of -1 times the square root of +25. The square root of -1, which is stated here, is equal to I. So that'll be I times the square root of 25 is 5. I times 5 is 5i. So basically, bringing it back to what I was saying up here, we know the square root of 25 is 5. The square root of a negative value will give you I. So that's how you could tell that it's 5i. Now, well, let me do number 3 as well. Square root of -36. Using the same logic, the square root of 36 is 6. The square root of the negative will give you I. So it'll be 6i. Now, number 5 takes a little bit more work, but I'm going to jump to number 7 first. Let's do number 7, then we will come back to number 5. So we have the square root of a -9/16. Now, both of these are under the radical here. Now, this is what we could do with this problem here. We know the square root of 9 is 3. The square root of 16 is 4. And the square root of a negative will give this an I, and the I will be in the middle. So your final answer would be 3/4 I, or you could write it as 3I over 4. Either one of these is fine. 3/4 I with I in the middle, or 3I over 4. The I is not supposed to be in the denominator in this problem. Okay, number 5. We have the square root of -48. Now, the reason why I said that this was a little different is because 48 is not a perfect square. So when we take this square root, we're still going to end up with something under the square root. So let's take a look here. The highest perfect square, let's disregard this negative sign for right now. Let's concentrate on this number being positive. The highest perfect square in 48 is 16. So we will add the square root of 16 times the square root of 3. We know 16 times 3 is 48. So since 16 is the perfect square, let's make that negative. So with this radical here, all we have to do is just bring it down, the square root 3 portion. Now, the square root of 16 is 4. The square root of the negative is I. So your answer is 4i times the square root of 3. All right. Now we move on to the next page. Now we go here. It says in exercises 9 through 13, perform the operations that express your answer in the form a plus bi. Use your graphing calculator to verify the results. Now, let's do problem number 9. They want us to have this in a plus bi form. So we add 2 plus 8i plus a negative 7 plus 2i. Now we will look inside the parentheses first to see if there's any like terms that we can combine. We have none here and we have none here. We look outside to see if there's any exponents or anything multiplied to the parentheses. We don't have either of those as the case. So what we would do here is this here. We could drop the parenthesis of the first. So that'll give us 2 plus 8i. And then because this has a plus sign in front of this parenthesis, we could drop this parenthesis as well. And this will give us negative 7 plus 2i. So now we would combine the like terms. Now remember, we want to get it in a plus bi form. So we combine the like terms. We have positive 2 and negative 7, which is negative 5. And then we have 8i plus 2i, which will give us a positive 10i. So your answer here is negative 5 plus 10i. Now they did ask us to verify our results in the calculator. So we will go right here and we could type this in as is. So we'll do our parenthesis, wait a minute, parenthesis, what's that, 2 plus 8i, close the parenthesis, plus, and then another parenthesis, negative 7 plus 2i. Okay, class, I was trying to prove using Desmos that this actually works in a calculator. But what I just found out is that Desmos has a very complicated way of doing complex numbers. So I'm going to show you another calculator specifically for Desmos only. I mean for the complex numbers only or imaginary numbers only that you all can access. It's very easy to access. I'm going to click here, and it's this website here, www.symbolab.com. And I'm going to click here and go to this calculator, and I'm going to type in the problem that we had here. So we would do our parenthesis. We had 2 plus 8i, close our parenthesis, and then plus parenthesis, negative 7 plus 2i. And then close our parenthesis. And then in order to solve this, you will press enter. And once you press enter, you come down here and it shows you the solution. It actually shows you the steps as well. Basically the same thing we basically did, and it gives you the final answer, negative 5 plus 10i. Okay, so now I'm going to leave this calculator up for a moment, and we're going to move on to As a matter of fact, I need to pull back up the textbook. Okay, we're going to move on to problem number 11. Problem 11. Hold on one second. For some reason this camera is acting up. All right, there we go. All right, number 11. We have 5i plus 3 minus 7i. So we have 5i plus 3 minus 7i. So inside this parenthesis, there's no like terms, no exponents on the outside, no multiplication. So we could take this out of this parenthesis, and since it has a plus in front of it, we have plus 3 minus 7i. Now, I'm going to have to do number 10 to show you what happens when there is a minus sign in front of the parenthesis, but we'll get back to that. So now we would combine like terms. Remember, we want an a plus bi form. So we would combine like terms. So we have our 3. 5i minus 7i is a negative 2i. Now I'm going to also do number 10. And then we're going to put this into the calculator. So we will have 5 minus 3i minus 2 minus 6i. Now, there are no like terms inside these parentheses. There's no exponents on the outside or nothing multiplying on the outside of the parentheses. So this first parenthesis we would drop. So we have 5 minus 3i. Now this second parenthesis, since it has a minus sign in front of it, it changes the sign of everything inside this second parenthesis. So this would be negative 2 plus 6i. So now we would combine like terms. We have 5 minus 2, which is 3. And then negative 3i plus 6i is a positive 3i. So now we're going to go right back to that calculator we had. And we're going to put these values in and get our answer. So after we do this, we could come here. Now I would tell you this, when they ask you to accept cookies, I don't accept cookies. I just, work around this because this isn't, it's not like we have a lot of lessons dealing with the imaginary numbers. So you're not going to need this calculator that much. So now we go here. We have our parenthesis. I'm going to do number 10 first. 5 minus 3i, close your parenthesis, minus, open parenthesis, 2 minus 6i. And close your parenthesis and press enter. Now we have our final answer here, 3 plus 3i, like we have here. Now we go to problem number 11. Problem number 11 was 5i, then plus the parenthesis, 3 minus 7i, close your parenthesis, and then press enter. And we have our negative 2i plus 3. They didn't write it in an a plus bi form, but as you see here, it's the same thing. Okay, so now we will go back to our textbook. Okay, so we're going to look at problem 13 now. And we have two parentheses here multiplying by each other. 4 minus 3i, 1 plus 2i. So now we will multiply like we did before with regular values that wasn't I. So we would do the FOIL method or distributive property. So we have 4 times 1 plus 4 times 2i. Then we would take our negative 3i. Negative 3i times 1. And then negative 3i times 2i. So now we multiply this. This would be 4 plus 8i minus 3i minus 6i squared. So we need to change this 6i squared. I squared we know is -1. So it'd be minus 6 times a -1. So this will be 4 plus 8i minus 3i plus 6. Now we will combine the like terms. 4 plus 6 is 10. And then 8i minus 3i is a positive 5i. So our final answer here, let me write it over here because I ran out of space. It'll be 10 plus 5i. That will be our final answer. Okay, so now we're going to put this in the calculator. We go right back here to our calculator. We would type in what we have here. So we have parenthesis 4 minus 3i. Then our other parenthesis of 1 plus 2i. Then press enter. And we have our answer here, 10 plus 5i, which we have. Okay, so now we move on. We're going to go to the next problem. Let's get the textbook back up. Our next problem is going to be problem 15. So the directions state in exercises 15 through 18, solve the quadratic equations in the complex number system using the quadratic formula. Verify your real solutions graphically. Verify that no real solutions mean no x-intercepts. Okay. So what's nice about problem 15 is already set up in the quadratic form. So 3 in a basic form, 3x squared minus 2x plus 7 equals 0. Now, we don't have anything we can factor out here. So we could list our a, b, and c. Our a is 3, our b is -2, and our c is 7. So now we would do our formula, which is x equals -b plus or minus the square root of b squared minus 4ac all over 2a, quadratic formula. So we're going to substitute. We had the opposite of -2 plus or minus the square root of -2 squared minus 4 times 3 times 7 all over 2 times 3. So it'd be x is equal to 2 plus or minus the square root of 4. -4 times 3 is -12 times 7 is a -84 all over 6. All right. So now we will have x is equal to 2 plus or minus the square root of -80 all over 6. Now, -80 actually has a perfect square in it. So we could rewrite this as 2 plus or minus the square root, the highest perfect square in 80 is -16. And that will leave you the square root of 5 all over 6. So you have x is equal to 2 plus or minus the square root of -16 is 4i times the square root of 5 all over 6. Now, we could do this a few ways, but what I would suggest that we do is this here. 2, 4, and 6 all has 2 in common. So we could divide all 3 of these values by 2, and this will leave us 1 plus or minus, and then this will be 2i square root 5 all divided by 3. Now we could leave it like this, or we could write it as 1/3 plus or minus 2i square root 5 all over 3. So either one of these is correct. Now they ask us to prove using the graphing calculator, which in our case would be Desmos, that this does not have an x-intercept. Because remember, since this is equal to 0 and we know y usually occupies this space here, x-intercept is when y is equal to 0. So let's go here and let's go to Desmos and let's type in this equation. So we have 3x squared minus 2x plus 7. Now, how we prove that this does not have an x-intercept is that it doesn't hit the x-axis. This graph never hits the x-axis, so that means it never has an x-intercept, which means that it will not have a real number solution. And we cannot graph in imaginary lines on this coordinate plane, so that is why we have no x-intercept. So even though this is the solution, it's still no x-intercept for this problem. So you will write no x-intercepts. All right. Now, let's go down to problem 19. So I'll have you try 17 on your own. So problem 19, let me pull that back up here. Let's say determine the number and type of solutions of each equation by examining the discriminant. So we look here at 19. We had 2x squared plus 3x minus 5 equals 0. Now, the discriminant, remember, is b squared minus 4ac. Now let's go through this process. We know a is 2, b is 3, and c is negative 5, because this is already set up for us. So we substitute in here. So we had 3 squared minus 4 times 2 times negative 5. So 3 squared is 9. Negative 4 times 2 is negative 8 times negative 5 is a positive 40. So this equals 49. So your answer here, because it's positive, let's go back. I think it was on page, 447. When we looked here at our discriminant values, if it's positive, it has 2 real solutions. So that means it has 2 real solutions. Now we move on. Let's go to 21. And then 23 will be our last problem. So it'll be 4x squared minus 4x plus 1 equals 0. Okay? So it's the same thing here. A is 4, B is negative 4, and C is 1. So we have B squared minus 4AC. The B is negative 4. A is 4, and C is 1. So this would be 16 minus 16. So this equals 0. So it's only one real solution. And you can look back at the definition on page 447. Now for 23, we had 12x squared is equal to 4x minus 3. Now we have to get this equation to equal 0, and we typically want our variable squared to be positive. So we'll subtract 4x and add 3 on both sides. So we had 12x squared minus 4x plus 3 equals 0. So A is 12, B is negative 4, and C is 3. So we have our B squared minus 4AC for our discriminant. So we have negative 4 squared minus 4 times 12 times 3. So this will give us 16. Negative 4 times 12 is a negative 48 times 3 is a negative, 144? So 16 minus 144 is a negative 128. So our answer is negative. So it's two complex solutions. And that is it. Now we're going to go on to the next lesson, which is 4.8. But if you have any questions from 4.7, feel free to contact me. And remember, you must complete all problems 1 through 23 odd for this section. So let's go back to the syllabus. 4.8 starts on page 463, and we're doing 1 through 15 odd. So we'll go here to 4. Let me see if I could. Oh no. Let's see if I could skip ahead a little bit. All right. Now let's take a look here at this summary activity. And I may have to write this down myself. It says the equation y equals kx to the n, where k is not equal to 0 and n is a positive integer, defines a direct variation function. The constant k is called the constant of variation. Okay, now the direct variation functions that have equations of the form y equals kx to the n, where n is a positive integer, are also called power functions. Power functions in which n is even resemble parabolas. As n increases in value, the graph flattens near the vertex. Power functions in which n is odd resemble the graph of y equals kx to the third. If k is positive, the graph is increasing. If k is negative, the graph is decreasing. So we'll be coming back to these definitions. So if we look here down at number 1, it says for each table, determine the pattern and complete the table. Then write a direct variation equation for each table. So it says y varies directly as x. So first of all, we can look back up here. The direct variation is y equals kx to whatever power. So y is equal to kx to whatever power. Now they didn't tell us a power here, so we're going to assume that it's to the 1 power. So this is the equation that we're using for direct variation. All right, so let's look back here. We want to find out what k is equal to because we know x and y are variables, so they could change, but your k would stay the same. Oh, and I'm out of the shot. All right. So again, y and x can change, but your k would remain constant. So look here. In this table, they give us x and y here. When x is 1, y is 8. So let's put this here. We put 8 here for y, k, and then x will be 1. Now we know 8 equals k times 1 is just k. So we just found out that k is equal to 8. So now your new direct variation would be y is equal to 8x. So anything that you have here, all you have to do is substitute it in, and you can find out what the rest of the answers are. So let me draw the table up here. So we have x, we have y, we have 1/4, 1 and 8, 4, then 8. All right. So now we would take these x values and put it in for x, and then we can find our y. So if we had, as a matter of fact, now that we have this equation, why not utilize Desmos? Now that we have our equation, we could type in y is equal to 8x. And then we could hit this wheel, hit the table, and then we could type in the values. So we already have what 1 is. We could put in 4. So then that'll be 32. We could put in 8. That'll be 64. And then we can even put in the 1/4. And that will give us 2. So now we filled out this table. All right, now, or you can do it by hand. There's nothing wrong with doing it by hand. Okay, so now we move on to the next page. Now we have B. It says y varies directly as x cubed. So now, if we go back to the previous page, let's look at the direct varies. I think it said, let me go back here. Did it say varies directly? Yeah, okay. It says varies directly. So it's just basically the same as what we did here in problem number 1 when it says y varies directly as x. But in this case, y varies directly as x cubed. So we'll write y is equal to k x to the third power. Because remember, it's y equals kx to the n, and in this case, n is the third power. Okay, so now we have another table. So we have x and y. What? 1/2, 1 and 1, 3, and then 6. All right. So now we go through and we need to find what k is. So here y is 1, and then x is 1 here as well. So this would be 1 is equal to k, because 1 to the third is 1 times k is k. So now we know what k is. So we could write our equation, y is equal to, now you could write out 1x to the third, or you could just write x to the third, because we know that, that the k is 1. All right, so now that we have this established, now we just take all of the values for x to the third power. 1/2 to the third power will give you 1/8. 3 to the third power is 27, and 6 to the third power is 216. So that fills in the table. All right, now we go down here to number 3. It says assume that y varies directly as the square of x, and that when x equals 2, y equals 12. Determine y when x is equal to 8. So we need to write out this initial formula, because it says y varies directly as the square of x. So we have y is equal to kx squared. Now they give us what x and y is equal to. X is 2 and y is 12. So we will substitute this in so we can find out what k is equal to. So we have 12 is equal to 2 squared is 4 times k is 4k. Divide each side by 4, and 3 is equal to k. So you have y is equal to 3x squared. All right, so that is your formula. Now they ask us to determine y when x is 8. So now we will substitute in 8 for x. So this would be y is equal to 3 times 64. So y is equal to 3 times 64, looks like it's 192. So your answer here is 192. All right, number 5. Let's see. Okay, number 5, I'm going to have you all try on your own. Okay, now it says in exercises 6 through 10, sketch a graph of the given power function. Verify your graphs using your graphing calculator. Okay, listen. You could just put this in your calculator to verify your graph, because it's better to look at it in the calculator. So let me write down number 7. We have y is equal to x to the 4th plus 1. So now we will come here and we will put this in our Desmos calculator. So we have y is equal to x to the fourth power and then plus 1. Okay, now, as you can see, this graph here, here's the graph. And this is what you would need to have graphed on your in your textbook. And you can click on some points here if you wanted to get some basis of some points. This right here, 0, 1, and then we got these points here, and you could keep going. All right. So number 9 is basically the same thing. You just put this in the calculator, and you could graph that as well. All right. We move on to the next page. Now it says number 11. It says determine the x interval over which the function f of x is equal to 1/2 x to the fourth is increasing. Okay, so let's take a look here. Now we know f of x is really just y. So we could say y is equal to, I'm just going to write that here. Well, we know it's f of x is equal to 1/2 x to the fourth. But just to make it easy in your calculator, you could type in y is equal to 1/2 x to the fourth. So let's go here to your calculator. So we have 1/2 then we will have x to the fourth. Okay, now we see this graph here. Now we want to talk about how the graph is increasing. Where's the graph increasing at? So if we look here, the graph basically goes down here at 0, 0. Okay, if you're looking at this graph here, you notice it came up, and we're going from left to right like we're supposed to read a graph. From going from left to right, it's going down relative to the y values as well. So we're going along the x-axis. The graph is going down until you hit 0. Now, once you hit 0, it starts increasing from a little bit above 0 on. So your answer with the increase, f of x is increasing for x is greater than 0. X has to be greater than 0 in order for the graph to increase. Okay. Now let's take a look at problem 13. I think we're supposed to go up to 15. Yes. Okay, let's take a look at 13. It says for x is greater than 1, is the graph of y equals x squared rising more quickly or more slowly than the graph of y equals x cubed? Explain. Now I should actually have you all do that problem, but let's take a look at it. Okay, for x is greater than 1, which one is rising more quickly? Y equals x squared or y equals x cubed? So let's go to our graphing calculator so we can get a visual look at this. So we know we had y equals x squared. And then we have y equals x cubed. And we ask which one is growing more quickly. Okay. Now, if we look at this graph here, now there's a couple ways we could do it. We could just do a table. Well, let me show you that. Okay, once we get here, we can hit the wheel. We can hit a table. And then we could click here, hit the wheel, hit a table. Okay, so now if you notice here, we have the same values for both, but we're more so concerned with all of the values that's greater than 1. So with the x squared, let's do about 2 more values. Let's do 3 and then 4. Now, if you notice from 1 to 4, it went 2, it went to 4, 3, it went to 9, 4, it went to 16. Okay, so let's go here. So we go 3, then we also go 4. We have the same exact values with the values being greater than 1. If you look here, well, let me see something. So I want to try and get these in the same, how can I say, the same shot. All right. All right. Yeah, they're basically real close. Okay, so, all right. Now this is the x squared. Now, we're going to start out, well, we could look at 1. Both of them are the same at 1. But we're looking at greater than 1. So we look at 2. With this 2 here with the x squared, the y is 4. 2 here with the x cubed, y is 8. 3 here with the x squared, y is 9. 3 here with the x cubed, y is 27. As you see here, as your x increases, your y's get exceptionally larger than the y's here. So it's increasing at a faster rate with the x cubed. So you could say here, and that was problem 13, x cubed is increasing at a faster rate because in the table I used every value greater than 1 produced a higher answer than x squared. And that's how you could do it using your graphing calculator. All right. Now, as far as problem 15, I want you all to try that on your own. So we're actually done with section 4.8. So now we're going to move on and go on to section 4.9, which will be the last section of this week. So let's take a look at the syllabus. 4.9 starts on page 470 and it's 1 through 9 odd. Let's go here. Say 470. All right, I want us to take a look. Page 470 at the summary. Okay, now, polynomial functions are defined by equations of the form output equals polynomial expression involving the input. Number 2, the largest exponent n on the input variable is called the degree of the function. Number 3, polynomial functions are continuous with domain consisting of all real numbers. Okay, then we come here to number 4. Polynomial equations of the form polynomial expression equals 0 can be solved graphically by locating the x-intercepts of the graph of the function defined by y equals polynomial expression, or algebraically using factoring if possible in a zero product property. Okay, we're going to get to all of this as we go through these problems here. Now again, we're supposed to go through problems 1 through 9. So let's take a look here at problem number 3, but let's read the problem. It says, in exercises 1 through 3, determine the x-intercept of the graphs of each polynomial function using algebraic approach, factoring. Verify your answer using your graphing calculator. Okay, so number 3, we have h of x is equal to x to the 4th minus 13x squared plus 36. Okay, now, first thing we do, we try and find the greatest common factor, which we learned in some previous lessons. And if you look here, our greatest common factor, whether it be the number or variable, is just positive 1. They really have nothing else in common. Now, this is a trinomial, so we can try a couple things here. One, since our lead exponent is an even number, which is x to the 4th, we could try, well, we could try factoring whether it was x to the 4th or not. So let's just try our regular factoring. So we're going to do a, b, and c here. A is 1, b is negative 13, and c is 36. Okay, so we take a times c, which will give us 1 times 36, which is 36. So we're going to take the factors of 36, which is 1 and 36, 2 and 18, 3 and 12, and 4 and 9. Oh, 4 and 9 and 6 and 6. Okay, these are the factors of 36. Now remember, we want two numbers that multiply together give you 36, but added together will give you a negative 13. Now, if you notice, all of our factors here are positive, but we know there's another way to get a positive answer with multiplication besides a positive times a positive. If we make both values negative, it will also produce a positive value when we multiply. But when we add, it will give the negative value that we're looking for. So this would be negative 37, negative 20, negative 15, negative 13, and negative 12. We're looking for the negative 13. So we will use negative 4 and 9. So we had h of x is equal to, we will have x to the 4th, and then we will have minus 4x squared, because that's an x squared, minus 9x squared plus 36. Now we group the first two values. We can factor out an x squared, and that will leave us x squared minus 4. We group the second two values. They had negative 9 in common, and that will leave us x squared minus 4. I forgot to put the square here. Okay, so it's x squared minus 4, x squared minus 4. The two parentheses are the same. So we will have in one parenthesis x squared minus 9, and another parenthesis x squared minus 4. Now, these are the difference of two squares, so they can still be factored. X squared minus 9 becomes x plus 3 and x minus 3. X squared minus 4 becomes x plus 2 and x minus 2. Now looking back at this here, we want to determine the x-intercepts. So we know x-intercept is when y is 0, so we will make this h of x equal 0. And we will bring down the values that we have here. Now we will have to set all four of these values equal to 0. So we have x plus 3 equals 0, x minus 3 equals 0, x plus 2 equals 0, and x minus 2 equals 0. Subtract 3 on both sides, x is negative 3. Add 3 on both sides, x is 3. Subtract 2 on both sides, x is negative 2. Add 2 on both sides, and x is 2. So now we have our answers, our x values here. So now we have to write them as ordered pairs to show the x-intercepts. So negative 3, 0, 3, 0, negative 2, 0, and also 2, 0. And these are all of our x-intercepts. Now, we'll move on. Let's take a look at number 5 here. It says, consider the function defined by f of x is equal to x to the fourth minus 6x cubed plus 8x squared plus 1. Use your graphing calculator to sketch a graph of the function. Okay, so let me write this down. Then we're going to use our graphing calculator to sketch this function. So we could have x to the fourth power minus 6x cubed plus 8x squared then plus 1. All right, so we have our graph here. All right, now let me pull the textbook back up. It says use your graphic calculator to sketch a graph of the function. So we have that. All right. Or we could actually draw it, just to do a little sketch. Doesn't have to be anything fancy. Somewhat like that. Just put some arrowheads on there. Okay, so we look here at B. Determine the domain of the function f. So remember, our domain deals with our x values here. So if we look here at this graph, there's no, even when we going out, there's no restriction on the x value here. So the domain is all real numbers because there's no restriction on x. Now we go here to C. It says determine the range. Now, let's take a look here at this graph again. Now, if you notice here, as far as y is concerned, there's no bound as far as the y is increasing. But there is one bound here where y cannot go lower than. So if you notice here, y lowest point is negative 8.915, or you could do negative 8.92 or something like that. So basically, the range is y is greater than or equal to a negative 8.92, or you could put 8.915. So your range is y is greater than or equal to a negative, well, let's just do 8.915. So y will be greater than that. That is for your range. All right. Now we move on to D. Now D, it says use your graphing calculator to estimate the x-intercepts of the function f. Okay, so let's take a look back here at the graph. And we know our x-intercept is where the graph hits the x-axis. Now we can round this to 2 decimal places since it already tells us that it's an estimate. So our x-intercept would be 2.12, 0, and then also it would be 3.97, 0. So those would be our x-intercepts. All right. Now we're moving on. I'm going to do problem number 9. I'm going to let you all do number 7 on your own. But I'm going to finish this off with problem number 9. It says, consider the following graph of y equals f of x. Now we look here at this graph here, and it says as x decreases without bound. Now when they say without bound, that means that it's going on forever. So if we look here, as x decreases, the corresponding y values do what? So the more x increases, the more the y values actually increase as x decreases. So then 9a, your answer here would be increases. Because as x is going down, because we know on the x-axis is negative over here. As we notice here, y is going up to the positive range. So it's increasing. Okay, B. Is the function f increasing or decreasing? Now they're saying here we need to look from about -2. I'm assuming that this is the start of this graph because this is listed here. So we look here, let's see, 2.5, let's see, okay. So they want us to do this from -2 to 2. So we actually have to do a little guesstimation here because like I said, this is the y-axis, this is the x-axis. You notice for, this would be the 0 here. So if you go here for every 3 here, you notice it goes up to it goes up by 2.5 or down by 2.5. So you got 1, 2, -2.5, 1, 2, then -5. And we know 3 does not go evenly into the 2.5 interval. So we're going to have to do a little bit of assumption here that most likely it's going to be somewhere up in here to somewhere up in here as far as this 2.5, this -2 and 2. So it says, is the function increasing or decreasing between these two values? So if you look at it, the function is decreasing because your y values are going down at that point. So it's decreasing. Because just like here, it's trying to find what's going on with the x. It tells you the x values, so you have to see how it's affecting the graph by the y value. Okay, now, C. How many turning points does the curve have? Now, a turning point just basically goes like this. You're going from left to right. Does the graph go down, then go up? Like, for instance, here, the graph is going down. But then when it gets down to its lower point, it starts going up. So it has only one turning point here. It's only one turning point. So we will put, it's only one. Now, if you want to see something that had more than one turning point, if we go back here to this little representation I had here, this would actually have, let's see, this would be one turning point. This would be the second turning point. This would be the third turning point. So it actually had 3 turning points. So that's basically it here. Now, we are done with this week's lesson. And like I said, if you have any questions, please contact me. Have a wonderful day.